Hello. Where is teacher Mark? Hello, teacher Nansen. Hello, hello. Can you hear me? Can you all hear me? If you can hear me clearly, you can just type a 1 in the chat to let me know. Hello. Right, cool. Nice to see you guys, and we will be starting at 2 p.m. sharp, just like the previous 2 days. How are you understanding the topics of the last 2 days? All good? Hello. So today we are going to cover the contents from topic 22 to 29. And these are going to be the word problems. Okay? So this is what we are doing today. And we're just going to wait a little bit for everyone before we begin. Okay? So have you all been working on this book yet? The NMOS book? How many topics have you done already? You can just leave a number in the chat saying how many topics you've done to let me know. I'm just going to see how many chapters everyone has done. No, you haven't done anything? Zero. Oh. I hope that's not teacher Mark saying that. If teacher Mark himself hasn't done this book, then it would be a disaster. right, 3 minutes to go, guys. Is there anyone in my class? Where is Teacher Mark? Well, as my name shows, obviously I am a tiger. So I ate Teacher Mark for dinner yesterday. Okay. So it's about time that we get started, everyone. Where's Teacher Mark? I told you just now. I told you. Why not the teacher with beards? You mean Teacher Turner? Oh. Well, we take turns. We take turns. That's the official answer. And the non-official answer is that I ate Teacher Mark for dinner yesterday. Yeah. So, hello everyone. Today we are just going to talk about the word problems. And namely, on your NMOS book, if you have it, it's going to be from topic 22 all the way to topic 29. These are all considered as the word problems, okay? So we are just gonna get started with question, like topic 22 first. Just give me a second, I'm going to retrieve it in a while. So question, topic 22, the train problems. All right, now, if we are getting started with the train problems, we are just first going to understand what are train problems, all right? So basically, if you're considering the train problems, the classic characteristic of it is going to be that the train problems is going to consider the length of the vehicle. So it's not only just trains. Whenever in a distance problem, that the length of the vehicle or the object that is moving is prominent, then it would be the train problems. So in the train problems, you need to consider the lengths of the object that is moving in your distance traveled. All right? So basically, you can consider that in the train problems, there would be various cases. First of all, we would have the standard train problems, which when a train is, so this is the train, and now it's traveling forward until the first moment is when the front of the train enters a bridge, right? So this is the span of the bridge, and this is the instant when the front of the train is reaching the bridge. And now, as the train moves forward, there's going to be a specific moment which the train leaves the bridge. So the rear of the train is leaving the bridge. That is going to be the entire distance traveled by the train when it is crossing a bridge. So the definition of a train crossing a bridge is actually that it starts from the moment which the train's front reaches the bridge, and it ends at the moment when the train's rear exits the bridge. All right? So as for the total length, you can see that for the length traveled by the train, you are comparing the distance between the two occasions, and you can see that definitely we need to take the same reference point. Either it's going to be how much the front of the train traveled or how much the rear of the train traveled. And you can see that the distance is going to be adding up the length of the bridge together with the length of the train. This is the total distance traveled. Is that making sense? Of course, there would be more different types of train questions involving the case which when the train is passing through, say, like crossing by a light pole, or something like when two trains are coming towards each other, or two trains are chasing each other. So these are going to be the more various cases, but then essentially what the train problem is describing is that it's just going to be, and the bridge, nah. So it's just going to be saying that the length of the train matters when you are considering a train problem. Is that right? So basically, let's get back to some more explanations on that. Let's take a look at this example 1 question right here. All right? Example 1. So in example 1, we can see that a group of cars, each of which is 4 meters long, is moving in one straight line. And the distance between any two consecutive cars is 10 meters. Now we know that the speed of the cars is 4 meters per second. And we know the group of cars passes a bridge of 200 meters completely in 100 seconds. So how many cars are there in the group? Actually, we can consider this problem to be a train problem, because we know that we need to consider the entire length taken by the group of the cars. Is that making sense? So now, we can first try to illustrate the problem. So if you're trying to illustrate the problem, you can see that each car is 4 meters long, and there's going to be a 10-meter long space between every two cars. So you can consider this to be a train with each carriage being 4 meters, and the link between them is going to be 10 meters. All right, we can consider this group of cars as a really big train. Now you can find the total distance traveled by all of these cars, and the distance traveled is going to be calculated by the time, which is 100 seconds, multiplying the speed, which is 4 meters per second, and that goes to 400 meters. So now we know that all of these cars have traveled 400 meters to pass the bridge, but the bridge is only 200 meters, right? So it means that the length of the cars is going to be 400 meters, take away the length of the bridge, which is 200 meters, and that goes to 200 meters for the length of the cars. Now the question is asking us how many cars are there in the group. We know that for every 2 cars, there's going to be a gap between them. For 3 cars, there's going to be 2 gaps between them. So for all of these cars, there's going to be 1 fewer number of gaps than the cars. And if I'm just trying to calculate the number of cars, of course, I can use an equation to solve it. Or the alternative is that if I'm just adding an extra 10 meters gap, then I would have the same number of cars and gaps now, right? So now every car would have a 10-meter gap in front of it. So if I'm just trying to add 10 meters to the total distance, we can then divide it by the length of each group to know how many cars there are. So what I can say is that the number of cars is equal to 200 adding 10 meters, and that is divided by the length of each group, which is the length 4 of the car, adding the length 10 of the gap. So 210 divided by 14, that gives us 15 as the answer. So there's going to be 15 cars. Is that right? So this is a basic train problem, which, of course, these cars are camouflaging as trains. Okay, so that's for the first example question. Any questions from anyone? All right. So in that case, we can just try to look at the second example question. For this second example question, we can see that a train takes 45 seconds to cross an 820 meters bridge. And also it takes 35 seconds to cross a 620 meter bridge. We know that in these 2 scenarios, the train is going to be the same train, so the speed of the train is going to be the same speed. So what is different in these 2 cases? Definitely what's different is the distance and the time, right? We know that it takes 45 seconds to cross an 820 meter bridge. So this is how we can illustrate it. 820 meters for the bridge, adding the train length. That's the total distance. And it is the distance traveled by the train in 45 seconds. Second case, we have 620 meters for the bridge, adding the train length as the distance, and it is going to be the distance traveled by the train in 35 seconds. So if you are comparing about the 2 distances, what do you realize? The difference in distance is going to be 820 meters, take away 620 meters, because the length of the train, that cancels out, right? So that's going to be 200 meters, okay? And for the difference in time, it is going to be 45 seconds, take away 35 seconds, which is 10 seconds. So now, it means that the train can travel 200 meters in 10 seconds, and it is pretty obvious that the speed of the train can be calculated by the distance difference divided by the time difference. That's going to be 20 meters per second for the speed. Is that okay? So this is what we have for the example 2 question. Yes, that's very good. All right, so now let's try to finish a guided practice question together. Well, I'll give you some time to read the question first. It says it takes 65 seconds for a train to pass a bridge that is 1,200 meters long. The same train takes 85 seconds to pass a tunnel that is 1,600 meters long. So there are 2 things we're trying to find here. The first one is how long was the train? The second one is at what speed was the train traveling? So first of all, can anyone tell me what is the distance difference in the 2 cases? Would you just type it in the chat, please? Yes, very good, very good. So we can see that if you are just following the steps, you can try to draw the diagrams. The first one is going to be 1,020 meters long for the bridge and together with the train length. That's the total distance, right? And it takes 65 seconds to cross a 1,200 meter bridge. In the second scenario, we have the total distance being 1,600 meters, adding the length of the train. So this is going to be the total distance, and it takes 85 seconds for you to pass a 1,600 meter tunnel. So basically, from the previous example, we realized that the difference in distance is going to be 1,600, take away 1,200, that is 400 meters. And what is going to be the time difference? Yep, that's right. So time difference is going to be 85 seconds, take away 65 seconds, that's going to be 20 seconds, right? So first we can definitely calculate the speed already. The speed of the train is going to be 400, which is the distance difference, divided by 20, which is the time difference. That goes to 20 meters per second. Then, how do you calculate the length of the train? Yes, very good. Oh, it's not 200 meters per second, it's 20 meters per second, all right? 20. And as for how to calculate the length of the train, you just need to calculate the total distance traveled and then subtracting the length of either the bridge or the tunnel. Depends on which case you're considering. If you're considering the first case, then the total distance traveled is going to be 20 times 65 seconds, which is the speed multiplying the time. And it goes to 1,300. So after you take away the length of the bridge, what you have is going to be the length of the train. Okay, that's going to be 100 meters. All right. So if you are understanding this, that would be absolutely brilliant. And we are done with the knowledge in train problems. Okay. So that's what we have in train problems. And secondly, we are just going to move on to the clock problems. So for the clock problems, we need to realize that it is essentially very much similar in a sense to the distance problems, because you can think about the two clock hands as two people or something like that going around in a circle. So basically there will be stuff that are related to traveling, like journey problems. And at the same time, of course, there will be angles formed, right? So that's also a little bit related to geometry, if you want to think about it. Of course, the most important thing is to understand the clock. We know that there are 12 hours in half a day, or like on the clock phase, there are 12 hours. So it means that altogether, when the hour hand is rotating for a complete rotation, that's going to take 12 hours, which it would have gone through 360 degrees, right? So in that case, we can think about it like this. If an entire turn is going to be 360 degrees and it takes 12 hours, then every single hour is going to turn for 30 degrees. And for every single minute, the hour hand would be turning 0.5 degrees. As for the minute hand, it would rotate for an entire turn every hour. So it means that every hour, which is 60 minutes, is going to turn 360 degrees, and in every single minute, it would turn for 6 degrees. So now if you know the angle that each of these hands is traveling, this is the foundation of understanding all the clock problems, all right? And also, if we are referring to the angle formed, it's always going to be the angle between the hour and minute hand, like the smaller one, instead of the bigger one on the other side, all right? So, the second point here, if you're considering the chasing problems in the clock, for example, when they are starting with an angle away from each other, and you would like to see how much the minute hand is going to take to catch up the hour hand, you would just need to realize that you can use the angles that they're traveling through to be the distance difference and the speed difference between them. For every minute, it's going to be 6 degrees to go away 0.5 degrees. That's 5.5 degrees catching up distance, or like catching up angle for every minute. Okay? And lastly, we are going to talk about the number of times a certain angle can be formed in 1 hour. So apart from 360 degrees, or like 180 degrees, so like overlapping, forming a straight line, something like that. If you're talking about a regular angle, say 90 degrees, 100 degrees, 120 degrees, something like that, if you want to know how many times that this angle is formed between the hour hands and minute hands, you need to think about how the hands move. So let's say we're trying to form an angle of 90 degrees, and we want to know how many times does it happen from 5 p.m. to 6 p.m. So from 5 p.m., we know that it's going to start at an angle of 150 degrees, right? And the minute hand will be closing up with the hour hand because it is moving faster. At a certain instance, it would be forming 90 degrees when it is catching up. Now, after that, the minute hand will continue moving until the minute hand and hour hand overlaps. So the angle becomes 0 degrees at that point, right? But after that, the minute hand keeps on moving, so it would really just increase the angle between the minute hand and the hour hand until it becomes 90 degree again sometime. And finally, it would just keep growing until it's opening up to be more than 180 degrees, and it would just be chasing the hour hand again on the other side. All right? So you can say that in most hours, the angle is going to happen 2 times. But of course, there would also be some exceptions. Now let's take a look at the exception cases. For example, in the second example right here, we want to know how many times will the hour hand and minute hand form an angle of 90 degrees from 2 p.m. to 4 p.m. So you can see that starting from 2 p.m., the angle is smaller than 90, so it would gradually catch up with the hour hand until it goes further than the hour hand and form 90 degree once. And after that, the minute hand will keep moving until it becomes a straight line and catches up slowly, forming another 90 degrees just at 3 o'clock. All right, and from 3 o'clock to 4 o'clock, of course, we are starting with 190 degree already. And later on, the angle closes up and opens up again to form another 90 degrees. So can you say that altogether in these 2 hours, there will be 4 instances that the angles are forming 90 degrees? Of course not, because we are counting the 3 o'clock once from 2 p.m. to 3 p.m. But we are counting it again from 3 p.m. to 4 p.m. So whenever you're thinking about these kinds of problems, you need to realize that the first step is you can assume that every hour would have 2 instances of the same angle happening. But the second step is that you need to take away the o'clocks that have exactly the angle. For example, in this one, 3 o'clock would have exactly a 90 degree angle. So you need to take that away. Okay? So it's very important for you to remove the cases which you have double counted. So, with that in mind, let's try to get started with some sample questions now. Okay? You can charge yourself. If your battery is out, you can charge yourself. Go find a charger. So for this example 1, let's say we have the minute hand and the hour hand forming an angle of P degrees at 8:25 a.m. So we want to find the value of 10 times of that. Okay. So first of all, let's just try to find out what the angle is. We know that at 8:25 a.m., the minute hand will be pointing exactly at 5, right? And as for the hour hand, it would be moving away 25 degrees, 25 minutes away from 8. And we know that every minute is going to be 0.5 degrees for the hour hand. So first of all, let's calculate the hour hand. The hour hand is 25 times 0.5, which is 12.5 degrees away from 8, or the 8 mark. What about the minute hand? The minute hand is at the 5 mark. So there are 3 big marks that you need to consider between the minute hand and the 8 mark. So you can say that the minute hand is 30 times 3, which is 90 degrees away from the 8 mark. So altogether, we know that angle P is going to be 102.5 degrees by adding the 2 degrees up. All right, 90 degrees adding 12.5. So that's just going to be what angle P is. And now if I'm just trying to find the value of 10p, it is going to be 1025. Is that right? So this is what we have for the example 1. And now, if we are taking a look at example 2, this is going to be the type of questions which we would like to see for forming angles. So the question is asking us from 4 o'clock a.m. to 12 noon, how many times will the hour hand and minute hand of a clock form an angle of 150 degrees? So let's think about it. Now we are getting started with 4 to 12. So how many hours do we have altogether? We would have 12 take away 4, which is equal to 8 hours altogether. And we can just try to assume that there are 2 times in each hour. Then it's going to happen for 8 times 2, which is 16 times, right? However, do you still remember what we said earlier? We need to remove the old clocks that has exactly the angle of 150 degrees. So what are the old clocks that have a degree of 150 degrees between the hour and minute hands? We know that the minute hand is definitely pointing at 12 at any o'clocks, right? So where should the hour hand point at? So if the minute hand is pointing at 12, then it means that the hour hand should be pointing at either 7 or 5 to form 150 degrees, right? So it means that there will be 5 o'clock and 7 o'clock it has been double counted. That's the reason why for the answer, you need to take away 2 times for each of these o'clocks. And it's going to be 16 take away 2, which is 14 times altogether for the clock to form an angle of 150 degrees. Am I British? No, I studied there, but ethnically I'm not. All right, so that's going to be what we have for clock problems. For the third topic of today, we are going to talk about the meeting and chasing problems of 2 people. Yeah, might have a little bit of a sort of British accent, right? All right. So for the meeting and chasing of 2 people, first of all, for the meeting problems, we just need to consider 2 people starting from 2 different locations heading towards each other. So it means that the distance that you're considering in meeting problems is going to be the total different distance between them. And the speed you're considering is going to be the total speed between them, which is the 2 distances combined. Okay, this is very important. And if you're talking about the chasing problem, because we know that for the chasing problem, the faster one is chasing the slower one, right? Usually. And for the time taken to catch up, you would just consider the distance as the distance gap between them, or like how much the person behind is going to catch up, divided by the speed difference, which is how much the later person is faster. Okay? So these are the key differences between these two cases. The meeting problem, you always consider the sum. The sum of distances, the sum of speeds. For the chasing problems, you consider the difference, which is the difference in distances and the difference in speeds. All right? This is what's different. Secondly, we're trying to understand how the midpoint is important, because in various of these meeting chasing problems, there's going to be content about midpoints. So how are we trying to understand a midpoint? For example, in this diagram, we have Peter, we have Sean, and they are meeting 150 meters away from the midpoint, which is closer to where Sean starts. Now, you can see that if you're just trying to cut this entire distance into half and consider each half as being 1 unit, then you know Peter would have traveled 1 unit and 150 meters more. And the second one is the slower person, which is Sean. Sean would be traveling 100 meters less than 1 unit, which is half the distance. So if you consider the distance difference between the two of them, that would be doubling the distance from the midpoint, which is a total of 300-meter difference. And then we can use the distance difference and the speed difference to calculate the time it takes for them to meet, just like a chasing problem. All right, because we can then find out how much more Peter is traveling than Sean, and if we know how much more Peter is traveling than Sean every unit time, we would be able to find the total time. Okay. And lastly, a little bit of proportionality relationships between the DST variables. So when the time is the same, we would know that speed 1 to speed 2 is distance 1 to distance 2. Because if you're faster, you can travel further in the same amount of time. Or you can also write it as the time is equal to distance divided by speed, right? So no matter you take the first set of distance and speed, or you take a second set of distance and speed, as long as the time is the same, distance divided by speed is always going to be the time. Yeah? And now, of course, for the same reason, as long as you have the speed being the same, then distance divided by time is just going to be the speed, which is also the same. So you can say longer time, more you travel. Shorter time, the fewer you travel, right? And finally, this one's a little bit different. Which page it is? It's on 207. 207 for this one. Yep. So for the final one, it is a little bit different. If the distance is the same, we know that the distance is equal to the speed multiplying the time, right? So if it is the speed multiplying the time, then it means that if you have the first set of speed and time multiplied together, it's going to be equal to the second set of speed and time multiplied together for the same distance. The faster the speed, the shorter the time. The slower the speed, the longer the time. So you can see that in this case, the speed and time ratio are flipped. They are in inverse proportions. Okay? This is going to be the special case, which is pretty important. And I hope you guys can remember that to solve these questions, right? Okay. So if we're all fine with that, we can just try to get started with some sample questions again. Let's take a look at example 1. So we have Peter and Jane. They were traveling towards each other from town A and town B, respectively. Peter is traveling 1 hour earlier, and they meet each other after Jane had been traveling for 4 hours. Peter was faster than Jane by 2 kilometers per hour, and the location they met each other was 10 kilometers away from the midpoint of the distance. So you can try to find the total distance in kilometers between town A and town B. So, as the solution suggests, the first step is we can draw a diagram to analyze how much they have traveled and how much more have they traveled. So you can see that Peter is meeting Jane 10 kilometers away from the midpoint, right? So now in this case, you can see that Peter is traveling 20 kilometers more than Jane, as we have suggested earlier. But we also know that Peter is starting 1 hour early, right? So that's also a very important fact that we need to know. Because we know that they have been traveling for 4 hours together, and Peter was faster than Jane by 2 kilometers per hour. So technically, in the 4 hours that they traveled together, the distance of Peter, take away the distance of Jane, is going to be 4 hours multiplying the speed difference, which is 2 kilometers per hour, and that's going to be 8 kilometers difference in 4 hours. But then why does that lead to a 20 kilometer more distance traveled by Peter? It's because Peter is traveling 1 more hour than Jane. Okay? So now, it means that in 1 hour, Peter can travel 20 take away 8, which is 12 kilometers. So the speed of Peter is going to be 12 kilometers per hour. And the speed of Jane is going to be 2 fewer than that, which is 10 kilometers per hour. So now we can try to find the total distance between them. So Peter has been traveling for 5 hours, and the distance of Peter is going to be, in total, 12 times 5. Jane has been traveling for 4 hours at a speed of 10 kilometers per hour. So that's going to be 10 times 4. And this would be the total distance between A and B, which goes to 60 adding 40, that is 100 kilometers. Okay? That is the total distance between town A and town B. Okay. This is for example 1. Now, if we are moving on to example 2, you can see that is definitely a different question right here. A train and a car start traveling from town X towards town Y at the same time. All right? And both of them traveling from town X towards town Y. The train is traveling 76% faster than the car. However, the train stops at a train station in between the towns for 38 minutes. If the distance between town X and town Y is 85 kilometers and they both reach town Y at the same time, can we find the speed of the train in kilometers per hour? So now, first of all, we can just try to identify the relationship between their speeds and times. So we can see that altogether, if the train is going to be 76% faster than the car, it means that the speed ratio is going to be 176 to 100, which, of course, you can simplify it to 44 to 25, right? So if you know the speed ratio between them, and you know that they are reaching at the same time, it means that this 38 minutes is going to be very important. Now, the actual traveling time for the train and the car must be the inverse proportion of their speeds, right? As we have mentioned earlier, the speed ratio is going to be the opposite, or like the reflex, the inverse of the speed ratio. So now we would know that the time ratio is going to be 25 to 44. And where does the 38 minutes represent? The 38 minutes refers to the time that the train has traveled fewer than the car. So you can see that between 25 and 44, there's a difference of 19 parts. And this 19 parts is actually referring to 38 minutes, which means every single part is going to take 2 minutes. So now we know that the actual time traveled by the train is 50 minutes, and the actual time traveled by the car is going to be 88 minutes, such that they have a difference of 38 minutes. All right. So now, if the distance between town X and town Y is 85 kilometers, we would like to find the speed of the train. So that is going to be in kilometers per hour, right? So what is the time in hours for the train? That's going to be 5/6 hours. So we can calculate the speed of the train as the distance, 85, divided by the time, which is 5/6 hours, which is equal to 85 times 6/5, which goes to 17 times 6. So it's 102. Okay? And that's going to be in kilometers per hour. So this is what we have for the second example question. Yeah, definitely. I know that word problems is going to be something that many of you might not be best at, but at the same time, if you master every single type of word problems, it's definitely going to get you the marks in NMOS, because pretty much all the time, the word problems are very much fixed and stable. So there won't be too many different things that they can have about word problems. It's just changing the backgrounds, changing the numbers. But for the techniques, most of the time it's going to be the same techniques for each type of word problems. So if you can master every single type of them, you would be the word problem master. Okay? All right. I guess we can just try to take a break first. Should we just take a break first? And then after that, we will just move on to talk about the remaining questions in topics 25 and onwards. Or maybe we can do one more. There's quite a lot to cover. Yeah, let's do one more. 25, 6, 7, 8, 9. Oh. So let's do one more. 25. It's still going to be the speed problems, the change of speed for one person. So basically, if there's any speed change, you need to identify the constant variable in the questions. And it's going to be usually the distance. And then you can use that to form some equations. And the most typical one is going to be like the one I said. The distance is going to be the speed 1 multiplying the time 1. And that's the same as speed 2 multiplying the time 2 in both cases. Which 1 and 2, of course, that represents the speed and time of the first scenario and the speed and time of the second scenario. Yeah? So this is what we can do. And for the approaches, you can start with thinking about what do you already know about the scenarios. So what information do you have at hand? The second part is like, what do we not know about? Or like, what do you want to find in the question? And the third thing is to notice what is the constant variable. What is the constant variable? Okay? So here's also a little bit of a tip. If you're setting the time or speed as x, usually it's going to be easier because it will avoid the fractions you might have. But at the same time, if that's really necessary, don't hesitate to do it. And of course, always keep an eye out on the units, whether it's meters, kilometers, whether it's minutes, seconds, or hours. You need to pay attention to it. Okay? So now let's cut it short and get started with an example question right here. We have a Samuel right here going to school on Monday. If he walks there at an average speed of 60 meters per minute, he will arrive 6 minutes late. If he runs there at a speed of 100 meters per minute, then he will arrive 2 minutes early. So what is Samuel's speed such that he can reach school on time? Now we have a speed 1. We have a speed 2. We don't know what the time 1 is. We just know that it's 6 minutes late compared to the standard time. And also it's 2 minutes early compared to the standard time. But we don't know what the standard time is. So that's the reason why we can set the standard time as x meters per minute. X minutes. If you're setting the standard time as x minutes, then it means that the distance is going to be the speed 1, which is 60, multiplying the time 1, 6 minutes late, which means 6 minutes more than the standard time. So it's 60 multiplying x adding 6 is equal to 100 meters per minute multiplying 2 minutes early, which is 2 minutes fewer than the standard time. So this is how we can form the equation. 60 times in brackets x adding 6 is equal to 100 in brackets x adding 2. And now we can just try to expand the brackets and solve it. So we would know that 60x adding 360 is going to be equal to 100x, take away 200. In the end, we would have 40x equals to 560. And x is going to be 14. So what does that mean? It means that the standard time is going to be 14 minutes. So now, what is the speed that Samuel needs to reach school on time? That's what the question is asking. So it means that we need to calculate it again, right? So in 14 minutes, what is the distance that Samuel would need to travel? You can see that he walks there at an average speed of 60 meters per minute, right? If he is arriving 6 minutes late. So it means that we can calculate the distance to be 60 times 14 adding 6. Of course, likewise, you can also do 100 times 14 take away 2. and that is going to be 1,200 meters for the distance. And what should be Samuel's speed to reach school on time? The speed can be calculated as the distance divided by time, which is 1,200 divided by 14, and you can just round it off to get the nearest meter per minute. So 1,200 divided by 14. Well, to save some time, I'm just going to use a calculator. That goes to 86 meters per minute, roughly. Okay. Is that all right to everybody? Okay. Nice. So in that case, we are just gonna look at... Ooh, we're already at the challenge. All right, so let's take a quick break, and this time it's gonna be for real. Yeah, let's take a quick break, and we will be back for the ratio word problems. So let's take a break for 7 minutes, all right? And we'll be back on 3 p.m. sharp. You don't understand why it must be on time. Let's get back to the question. For the rest of you, if you need to take a break, you can go. We will be back on 3 p.m., all right? It's because the question was asking about it, okay? So, you see, the question is asking you, what is Samuel's speed so that he can reach school on time? Yeah? And reaching school on time means that it's going to be the standard time to reach school. So first of all, we can set the standard time to be some unknown. After finding it, we can then use the distance that we found to divide that by the standard time to get the standard speed required. You mean you don't know why x has to be that? It's because it's going to be easier for you to express it. Because both of these descriptions, 6 minutes late, 2 minutes early, they are with reference to the standard time. Yeah? So they're comparing to the standard time. That's the reason why it would be easier if we set the standard time as the unknown. You don't understand why must Samuel be on time? Because Samuel is a good kid. Samuel wants to be on time, wants to be punctual. All right, I'm just gonna go for a water break, and I'll see you in 5 minutes. Well, surely Samuel can also arrive a little bit earlier. Come on. This is just how maths questions are like, right? It's not 100% of the time being very realistic. Do you think the lesson is boring? No. I mean, how? Word problems is one of the most interesting topics. You can see all sorts of different weird backgrounds. Where is teacher Mark? Well, it's pretty obvious. I have told everyone a lot of times already. I ate him for dinner yesterday, so he won't be here today. Yeah, that's okay. If you need to go at a little bit earlier time, that's fine. Right, it's 3 o'clock now. Let's get going. You're ready, guys? You're back to your screens. Ready for that? Just type me a 3 if you're ready. Type a 3 in the chat box. Exactly. I eat my colleagues to keep me surviving. Yeah, that's right. Okay. Right, so the next thing is the ratio word problems. I mean, the ratio word problems is one of the things that quite some of you might be a little bit stuck at. The ratio problems is usually a little bit abstract. Yeah. Tomorrow is going to be teacher Mark again. Yeah. I was just kidding. I didn't actually eat him, of course. Right. So for the ratio word problems, especially when you need to connect the ratios, that's where the key is. So now let's try to do a little bit of a practice on connecting ratios. So if you have some simple questions, for example, if, say, A to B is 1 to 2, and B to C is 3 to 5. How do you connect the two ratios? Of course, when you are trying to connect these two ratios, first of all, you would need to find out what is in common between the two ratios, right? Which is B. And then, in both of these ratios, you will try to make it the same number of parts, such that when you are doing A to B to C, B is 2 parts in the first one, 3 parts in the second one. So finding the lowest common multiple of it, it would go to 6 parts. And then you're just trying to match the two ratios with the 6 parts right here, and you will be able to get the connected ratio between A and B and C, right? So A would become 3 parts, and C would become 10 parts. Is that right? Now we know A to B to C is going to be 3 to 6 to 10. Is that okay? So that is how we can connect two ratios when there's something in common. But of course, in the more complex ratio word problems, being the same quantity is not what we are trying to consider. The first type of it is when the total is unchanged. For example, you have some oranges in basket A and basket B. Originally, they are in the ratio of 1 to 2, and you're transferring 10 oranges from basket B to basket A, then the ratio becomes 2 to 3. But we know that actually the total number of oranges in both baskets has been unchanged, right? It's just that the allocation is a little bit different. So it means that we can try to set the total as the unchanged quantity. So now, we would be able to say that in the first ratio, there are 3 parts in total. In the second ratio, there are 5 parts in total. So altogether, we can just try to make it 15 parts as the lowest common multiple of the 2 numbers. And you can just try to distribute that in a 1:2 ratio or a 2:3 ratio to match the number of parts before and after. And then you would be able to use the change in the number of parts to analyze how many sort of quantities, like what's the quantity of whatever that is in the question. Okay? So that's when the total is unchanged. As for the second type of it, we would have the cases which the difference is unchanged. And it is very common in sort of like the age problems, because age is one of the things which, well, if we grow by some age, we are growing together. Or if you're thinking about a few years back, then the age will also drop together, right? So like for the 2 people that are considered, the age difference is always going to be the same. But of course, that's just one of the scenarios. There can be some other scenarios as well, okay? But in general, when the difference is unchanged, then you just try to calculate the difference in the number of parts in each ratio and try to make them the same. So just like in this question, if I have Belinda's age a third of Jason's age, then they're in a ratio of 1:3, right? With a difference of 2 parts. 10 years later, the difference is still going to be the same between them, but the age ratio changes to 3:7, and the difference is 4 parts now. So if you want to compare these, you can just try to expand the first ratio into 2:6, such that the difference is also going to be 4 parts. Now you know that this is going to be growing by 10 years for every part of the difference, right? Yes, 1 unit is going to be 10 years. Very good. All right, and as for the third type of scenarios, we have the external change ratio problem. So this is one of the types of questions which the before and after ratio have different changes. And we would not be able to find anything that is being constant. It might be, well, let it be the single quantities or like the total or like the difference. They are all changing, okay? So in this case, if they are all changing, then we're just gonna use algebra. This is the best way of doing it, all right? Using algebra to express the number of each individuals and use the algebra to list an equation. This is what you can do, okay? So we'll get there. But let's get started with example 1. So in example 1, we have Mr. Liu, who plans to distribute some sweets to his 3 students, Xavier, Yaoming, and Zaini, in the ratio of 3:5:6. But then he's made a mistake when passing out the sweets, and they ended up receiving the sweets in the ratio of 2:3:5. So if one of them received 10 more sweets than planned, how many sweets did Xavier receive from Mr. Liu? So let's think about it. For the sweets distributed, what is unchanged? Well, clearly they are in different ratios, right? And what's unchanged is that we know the total number of sweets is actually the same in the 2 different ways of distribution. Mr. Liu just made a mistake when passing out the sweets, such that the ratio gets wrong. But Mr. Liu didn't eat any of these sweets himself. he still passes all these suites to his students. Yes. So it means that in the first case, we can consider the total number of parts, which is 14 parts. In the second case, if we are considering the total number of parts, that's going to be 10 parts. So if you try to find the lowest common multiple between them, it's going to be 70. Which means for the first ratio, how many times do you need to expand it to get 70 parts altogether? You would need to expand it 5 times, right? So the 3 becomes 15. The 5 becomes 25. And the 6 becomes 30 to get 70 parts altogether. Secondly, if you're looking at the after case, how many times do you need to expand that to get 70 parts altogether? You will see that 5 goes to 35, because that's going to be 7 times from 10 to 70. And 3 becomes 21, 2 becomes 40. All right? So, if you are now comparing the number of suites received, you can see that both Xavier and Yumeng have fewer candies than planned. So it means that it has to be Ziny with more suites than planned. This is going to be an increase for 5 units, which is the same as 10 more candies, right? So it means 1 unit is going to be 2 suites. And how many suites did Xavier receive from Mr. Liu? Xavier gets 14 parts, or 14 units. Each unit is 2 suites. So Xavier would have got 14 times 2, which is 28 suites. All right, so this is going to be the answer for example 1. You can see that this is what we do when the total is constant, right? Okay, now. So let's take a look at example 2 to see if there's any difference between that. In example 2, we can see that a university encourages all faculties to thrive for a higher ratio of female students to male students. It must be NTU. In a previous year, a certain faculty had 1,473 female students and 2,023 male students. And I want to meet the target ratio of 3 to 4, which you are recruiting new students in a 1 male to 1 female ratio. So the same number of female and male students are recruited. And the new ratio became 3 to 4. So how many new students are recruited? Now, how do you analyze this? In this example, can you tell me what is unchanged? Is the total changed? Or is the exact number of males and females changed? Well, so you can see that in this question, what is unchanged is the difference, right? Because the number of males and females have been growing by the same number as the new students were recruited in a ratio of 1 to 1, right? You can see that's a ratio of 1 to 1 from this line. So it means that we are looking for the difference to be constant. In the first case, what is the difference? 2023 take away 1,473, and that goes to 550. All right. What about the second case? The second case, the difference is 1. So it means that how many times do you need to expand the second ratio? For 1 to go to 550, it needs to go 550 times, right? So it means that there will be how many male students? 2,200 altogether. And how many female students? 1,650. So, how many students are recruited then? We can see that each of them would have a difference of 177 parts. Yeah? And of course, each part represents 1 student because the previous year, the before ratio, have each part as 1 student. So, of course, now, even if you're adding 177 parts for each of the males and females, that's still going to be 1 student each, right? So it means that altogether, the number of new students recruited is going to be 177 times 2, which goes to 354 students altogether. Is that okay? Right, so this is example 2 for the case which the difference is constant. Now, if you're all fine with that, we can just take a look at example 3. Of course, in this topic, we do have example 3, huh? If you still remember the third case that we have been talking about, the third case we have been talking about is going to be about the external change cases, right? If everything's changed. So let's see, if this question has, at first, 40% of the students of P5 cohort of a particular school were boys, 10 boys are transferred out, and 20 girls are transferred in. And now, the boys have 35%, the girls have 65%, of course. So how many girls are there in the level now? The first thing we can realize is the before and after ratio. We know that before, we have the boys to girls being 40% to 60%, that is 2 to 3. Yeah? And after, we have the boys to girls 35% to 65%, that is 7 to 13. So you can just try to express the before 2 to 3 as 2U to 3U. The after 7 to 13 as 7P to 13P. And what is the change between them? We know that 10 boys are transferred out, right? So this is take away 10. And we also know that 20 girls are transferred in. So this is going to be adding 20. And now we would have 2 equations. The first one is going to be 2U take away 10 is 7P. The second one is 3U adding 20 is going to be 13P. So now if you're expanding the first one by 3 times and expanding the second one 2 times, you will be able to solve it. Well, basically it's just standard simultaneous equations. Solve them and you will be able to get the number of each unit and each part. So let's do this together. 6U take away 30 equals to 21P, and the second one is 6U adding 40 equals to 26P. So now we would be able to subtract the first equation from the second one to get 70 equals to 5P, P is equal to 14. So, how many girls are there in the level now? Because we already know that P is 14, the number of girls is going to be 13P, which is going to be 13 times 14. So it should be 182. Okay? $20. All right, do I sound like that? Okay, so that's for the ratio problems, guys. And of course, there's ratio's brother, fraction and percentages. Basically, for fractions and percentages problems, that's going to be very similar to ratio problems. Sometimes you can consider them as to be the same type of questions, but of course, there's a little bit of touches to the fractions or percentage work problems that's going to be different. And the first one is like we can have some working backwards techniques, especially for those step-by-step problems. For example, in this question, we have Vivian using 10 onions, and she's going to use half of the potatoes, 2/3 of the remaining onions, and blah, blah, blah. And what she has left in the end. So you can just try to express each of them. You can just express each of them by expressions, like units or something like that. And now you would be able to solve it, okay? And if you have multiple percentage changes, so for example, if the two parts of a whole change according to certain percentages respectively, and you also know what's the overall change, you can then just try to express it in, well, of course, algebra again, okay? To find the relationship between them. So this is what we can do in the percentage problems. Yeah. Okay. So now, example 1 of the fraction and percentage worth problems. It tells us that Frank had a total of 424 local and foreign stamps. He gave away 40% of the local stamps and 5/6 of the foreign stamps to his friends. And then he bought 28 foreign stamps. So now, the number of foreign stamps he had was 16 2/3% of the number of local stamps left. So how many local stamps did he have at first? Now, how do you convert 16 2/3% into a fraction? You can think about it as 50/3%, and that's going to be 50/300, which is a sixth, right? So this is actually the same as a sixth, if you think about it. So now, if the foreign stamps is a sixth of the local stamps, you can then, as the solution suggests, use 1 unit to represent the foreign stamps and 6 units to represent the local stamps. This is what you can do. And after that, let's think about the changes. First of all, for the local stamps, he gave away 40% of it, which means what he has left now is going to be 60%, right? So you multiply 1, take away 40%, which is the same as multiplying 60% of it. And as for the foreign stamps, he gave out 5/6 of the foreign stamps to his friends, which means multiplying 1, take away 5/6, that's going to be multiplying a sixth. And after that, he bought 28 foreign stamps. So it means that before that, if you work backwards, it's going to be 1 unit, take away 28. Yeah? And this is a sixth of what he has at first. So at first, he would have 6 times of 1 unit, take away 28 stamps. As for the local stamps, of course, this hasn't changed. So this is still 6U. And if you're multiplying 60% to get 6U, it means that originally there was going to be 10U, right? So now you can just try to analyze it in the last step. We know that Frank had a total of 424 local and foreign stamps in the very beginning, right? So it means that 6 times of U take away 28, adding 10U is going to be 424. And this is going to be 16U take away 6 times 28, which is 168, equals to 424. And now we know 16U is going to be 592. And we would be able to calculate U as 37, I think. Yeah, should be right. Okay. So the question is asking us how many local stamps did he have at first? And that's going to be 37 times 10, because that's going to be 10 units, right? So 37 times 10. And that is 370 local stamps. Okay, so that's for our example 1. Does anyone have any questions? Example 2. We can see that in example 2, we have the school canteen purchases the same amount of vegetables this year as compared to last year, and 25% more meat this year than last year. If I know that the total cost of vegetables and meat last year was 240,000, wow. And the cost this year is 290,000. So if the cost of vegetables and meat this year increased by 10% and 20% respectively compared to last year, and the school canteen spends $100 on vegetables, what is the value of N? Okay. So first of all, we know that the amount of vegetables bought is the same, right? So we can say that the vegetable purchased last year is going to be 1U, and the cost of meat purchased last year is going to be 1P. Yeah? So what about this year? For this year, the price of the vegetable is going up by 10%, even though the amount of vegetables hasn't changed. So it means that altogether, the same amount of vegetables is going to cost 110% that of last year. At the same time, for the meat has been more expensive. Yeah, and also the meat has been increased in the amount. So what we can say is that compared to last year, we have bought 25% more meat. So this is the amount of meat that we bought, 125% times last year. And at the same time, the price is going up by 20%. So we are multiplying another 120%. So now, in this case, what we can do is that we can just try to calculate what it is. 125 times 120. That goes to 6 times So that goes to 1.5. Yep. So basically we have 1.1 U adding 1.5 T is going to be 290000. And we also have 1 U adding 1 P equals to 240000. So now we can just try to wipe the points off by adding another 0. And then, of course, you can just try to expand each of these ones into 10 by adding another 0. So now we know that by subtraction, 1U adding 5P is equal to 500000. And comparing that to the original equation, we have 1U adding 1P is equal to 240000. So you know that 4 times P is equal to 260000. And 1P is going to be 65,000. So it means that originally 1U is going to be equal to 240,000, take away 65,000. That goes to 175,000. And this is going to be for last year, right? This year is going to be 1.1 times of that. So 1.1 U is going to be equal to 192,500. Okay? So it is going to be the same as 100N, which means N is going to be equal to 1,925. Okay? Yep, I'm just waiting if you have any questions. The most of it is just calculation. Once you have been expressing the new prices and the old prices under the same set of unknowns or criteria, then the rest of it is just calculating, and you should be fine with it. Okay? Any questions? Okay. All right, we are on topic 28 now. So for topic 28, we're talking about the work rate problems. You need to understand that the work rate problems is very much unlike the speed, distance, time problems. We know that the speed multiplying the time is going to be the distance, right? And in work rate problems, we can understand the work rate as the speed of work multiplying the time, and it is going to be the total work done. This is what's different about the work rate problems and the distance, speed, time problems. But of course, another thing about what is special is that we don't always have the work done as an exact amount. So that's the reason why sometimes we would need to consider the work done as one part or like one whole, and such that you can express the rate of work as a fraction, 1 over the number of days that it takes to finish it. For example, if I have one project to be done in 10 days, then the rate of work is going to be a 10th. Is that making sense? So now, what I have in this example here is that we have two teams finishing a project together, and we can see that if A works twice as fast, they can finish it in 6 days instead. But if they are working at normal speeds, they can finish together in a week. So what does that mean? It means that we can set the overall work rate of them to be 1 over 7, because if they can do it in a week, it means that every day they can do a 7th of the project, right? And now if I am doubling A's work rate, and they will be able to combining their work and finish it in 6 days. So that's going to be a 6th when they're combined. So you would be able to calculate the individual work rates of A and B now. Okay? Yeah. So that's what we have. So we can take a look at this example question right now. This example question is very interesting. We have one master and 3 apprentices working together, and they will be able to complete a task in 4 days. If I have 2 masters and 1 apprentice working together, they will take 3 days to complete the task. So let's say I have a master and 3 apprentices. The total work rate is going to be a quarter, because they can complete it in 4 days, right? So every day that's going to be a quarter. If I have 2 masters and 1 apprentice, that's going to be a work rate of a third. So how long will it take to complete the task if 1 apprentice is to work alone on the task? So now, we can first try to consider expanding the first expression 2 times, such that 2 masters and 6 apprentices would be working a half of the work per day. Yeah? And now, if you are then comparing these 2 expressions, you would be able to realize that if I am comparing 2 masters and 1 apprentice with 2 masters and 6 apprentices, by subtracting them, you would see that 5 apprentices is going to work a half, take away a third, which is going to be a 6th of the work per day. So how long does it take for 1 apprentice to work alone on the task? We know that 5 apprentices is going to take 6 days to complete the task, because they can finish a 6th of the work per day. So it means that 1 apprentice would have a work rate of 1 over 30, which means that it takes 30 days for the 1 apprentice to work alone on the task. Is that right? Yes, very good. Let's do another guided practice right here, such that I can just try to make sure that everyone's catching. So now you're going to have David and Emma working as a pair to complete a maths journal. So if working alone, David and Emma each needs 10 days and 18 days. So can you just work out the rate of David and Emma immediately? If it takes 10 days for David to finish the job, it means that every day, how much can David work? It's going to be a 10th, right? And what about Emma? Every day, David can work a 10th of the job, and Emma can work 1/18th of the job, right? And then the question says that David starts to work alone for some days and handed the work over to Emma. And the journal was completed in 14 days altogether. So now you will be able to solve it with algebra, right? Because we know that altogether it's going to be finished in 14 days, which means if Emma worked for X days and David would be worked for 14 take away X days. So now you can use an algebra to do it. We know that the total work is considered as one whole, right? So if Emma is working for X days, it means that altogether, Emma would have worked 1/18 times X of the work. As for David, David would have done 1/10 times 14 take away X days of the work. And that is combining to a total of 1, which is the entire job, right? Now, if you want to solve fractional equations, of course, you would not like fractions. You can just multiply both sides by 90. And by both sides, I mean every single term. So by multiplying 90, you can see that 18 becomes 5. And 1/10 becomes 9. Of course, on the right-hand side, we have 90 then. So altogether, we would be able to say that 126 take away 4x is equal to 90, which means 4x is equal to 36, and x is equal to 9. So we would be able to figure it out. Emma would have worked for 9 days. Okay? So that's basically how you can do the work rate problems. First of all, you can just try to express each of their work rates as a fraction, and then use these fractions to calculate it, just like the SDT problems. Okay. All right. And the last one that we are going to go to is going to be the average work problems. I'm pretty sure this is one topic that many of you likes about average work problems. So the first technique is, again, solving algebra. Algebra is a really powerful tool, of course. So if you're just trying to use some algebra to solve it, definitely that's going to be fine. All right. So, for example, in this sample question, we have the average height of some students being 160. Now, if Dennis, who is 171 centimeters tall, joined the group of the students and the average height increased to 161, what is the number of students at first? We know that the total is equal to the quantity originally times the average, right? This is a very important relationship in the average problems. So if you know this relationship, you would be able to calculate this question without any problem. So you would know that if you have 160 times x, that's the total height of the original student, adding 171, which is the height of Dennis, is going to be the new average multiplying the new number of students. So that's how you can form an equation with the total height of students that you're considering, and you would then be able to find the number of students. Yep. Or, of course, you can also use the bar model to express transferring excess to shortage, which is if you're considering this as the original average and this as the new average, say, using the same example as the previous question, the original average is 160, the new average is 161, and the new value is going to be 171. So it means that the extra person is contributing 10 to each of these people to grow by 1 in average, which means that there will be 10 people altogether, each going up by 1. Is that right? So this is what you can consider when you have it in a bar model. So basically, if you understand the bar model well enough, it saves you the trouble of doing algebra. But if you're good in algebra, definitely you can solve it with algebra. All right? That's definitely going to be fine. So, in example 1, let's take a look at this question. We have a class who took a test. If the highest mark, 96, is removed, the average mark of the whole class decreases to 75. If the lowest mark, 42, is removed, the average mark of the whole class increases to 78. So how many students are there in the class? We can use algebra. Let's say we are getting started with the number of students as x. All right. Now, in the first scenario, what it is describing is that if I am removing 96 from the original total, the new total becomes 75 multiplying 1 less than the original number of students, right? So we have 75 times x minus 1 as the new total, adding 96, that would be the original total. And what about the second case? If you're considering the second case, it's removing 42 and the new average is 78. So the new total is going to be 78 times x take away 1. And the original total is that adding 42. So in the end, we would be able to solve that 54 is going to be the same as 3 times x adding 1, x take away 1, which we know x take away 1 is just going to be, we don't need to expand it, we just divide 54 by 3, and that's going to be 18. So you know that x is going to be 1 more than 18, which is 19. And the number of students in the class is 19. All right? This is how you can use algebra to do it. All right. And what about the second example right here? For this second example, you can definitely see that if you have the full score of each common test being 100 marks, where Paul has taken 4 common tests, his average being 89. If he wants his average score to reach 95 or above, at least how many more tests should he take? Now, this is an interesting question. We can use the bar model to solve it, all right? First of all, we have 4 of these tests being 89. So let's draw a mark for 89. And let's try to draw another mark for the target average, which is 95. So there are 4 tests right here. So you can say there are 4 tests that Paul has already taken, the average being 89. So if Paul wants the average to go up to 95, it means that the difference you're considering right there is going to be 6 marks more in average for each test. So altogether, that would need 24 marks more to get to 95, right? But again, the full mark here is going to be 100, right? If you draw another line for the full mark 100, you would be able to see that for every single test that Paul has got full marks in, that would only be able to provide 5 marks to the original tests that had an average of 89. So at least how many tests do you need for the extras? So if there's just 4 extra tests with full marks, that will give a maximum of 20 marks, which is not enough for the 24. So it means that at least you should take 5 more tests. Well, Paul, not you. Such that it would be able to provide an extra 25 marks. So it's more than enough such that the average will go above 95, okay? It can't be exactly 25, but it will be above 25 in that case. So it means that you would need 25 more marks, or like at least 24 more marks, and at least 5 more tests to achieve that. Is that okay? So that's going to be example 2 of this last chapter we have. So now, as I still have a little bit of time, I am going to take some questions from you guys. So if you do have any questions in what I said just now, please let me know in the chat and I can just try to answer that for you. Any one of the previous topics that I have covered, 22, 29. Okay, anyone? Eight more minutes. You want me to carry on with some sample questions or what? You mean the average? Page 251. All right, let me get back there. 251. This one. Yep. Please feel free to go ahead. I am not really sure what is blue kit. Yes. Oh, so for the average problems, you don't really understand. Okay, I'll go back to that a little bit earlier, a little bit later. Do I have not lens in my glasses? Of course, there is lens in my glasses. Oh, booklet. You want some booklet to revise? Yeah, later. Okay. So for the average problems, basically, you just need to understand the basics of average. Everything starts with this formula, which the average times the quantity is the total, or you can say that the average is equal to the total divided by the quantity, right? Or divided by the count, basically. And in that case, if you understand what it is, then you just play it around, like you play around with the terms. For example, if I would need to solve an inequality about this, I can also do it. It just means that if he wants his average score to reach 95 marks or above, you can also list it as 4 times 89, adding 100x is greater than 95 times x adding 4. So you can do something like this. Say there are x more tests that he should take. So you can say 100x adding 4 times 89 is going to be greater than or equal to 95 times x adding 4. If you know how to solve an inequality. Topic 2, new operations. Yeah, of course. Of course. Topic 2, new operations is a nice topic, but I think we have covered it already. Did Teacher Mark cover that already previously? So yeah, if you want more of that, you can scan the QR code next to the challenge questions, then definitely you'll be able to get more from there. Yeah, today is more about word problems. So in this question, you can also try to solve this for x, right? There's not only one way of doing it. Okay. That's right, Kat. I mean, we can't just only do calculations, yeah? Calculations is great, but definitely that's not the only thing that NMOS has covering. So you need to be more all-rounded. You can't pick on the questions that you like. Well, there's still time. So if you think you're failing, you can try a little bit more. There's still time. Yeah, if you have no questions, then this is the end of today. You're free to go. If you still have any questions, please feel free to ask about it. No? Okay. All right, bye-bye, everyone. I'll see you next time when I see you.